You live, yeah.
And welcome. It is time to start our meeting. It is our 26th AI Manchester Statistical Society AI meeting. We organize them every month, and today I will come to today's meeting. Today we have the pleasure to welcome Ian Massingham. Ian is a senior technical executive, her experience in cloud computing, data technology, startups, develop relations, and currently he is Yes, Ian in a moment will tell more because these areas are really wide. This title will be also shared in a moment. Then please welcome Ian.
Sorry, I'm okay to put the mic on. Is that
Yeah,
okay?
that's
Thank
right,
you
yeah.
very much. It's a magnetic one, so that goes behind you.
Oh, that's sophisticated.
And then that should just click back on.
Okay,
Perfect, thank you.
great. Is this on?
Yeah.
That's it, I think, yeah.
He did a boost.
Oh, it's coming, I think.
Yes, there, yeah. Are you able to switch up the front line? Ask Janet. All right, no, it's going.
It's going, yeah. Cool, so thanks for inviting me, and I want to apologise for missing last week. I was sick last week, I'm still not 100%, but I had some flu medication thinking I would be fine to come over here last Tuesday, and it had the opposite effect. It absolutely destroyed me, and I could not drive to the station after taking it, but I'm here this week, so it's great to be here. My name's Ian, and as the host mentioned, I've been in the cloud space for quite a while. I started with Amazon Web Services in 2013, when it was still early. You know, when I joined, they had pretty much zero enterprise adoption in Europe, and I was lucky to be there through the growth period up to 21 and see it grow very quickly. But since 21, I've been doing a few different things. So I was at MongoDB for a year, so a non-relational data company where I was running a global function there. And then I got into startups seriously. I was 2 years at a Series D called Ivan, which is a data infrastructure startup headquartered in Finland. I was doing developer experience and product marketing there. And then about 15 months ago, I left there and I joined another company called GripTape. And GripTape is super early. We were like 15 people when I joined. We'd raised the seed round, so our first venture capital round of about $12.5 million. There were myself and a few other ex-Amazon people there in the leadership team. And most of the engineering over at GripTape was, predictably, that's not going to work, is it? Most of the engineering over at GripTape was also ex-Amazon people. Maybe I need to click somewhere. There we go. So a little bit about my background. I think I've covered that already. At GripTape, we've been on quite an interesting journey. So we started, when I joined, we were like here. So we were talking about creating cloud primitives to make it easier to run applications built with large language models and other types of generative models. So we were trying to create a framework and an operating environment that would make it simple for developers to create apps around LLMs. And I'll explain more what I mean by apps around LLMs in a second. But I don't know if you know, in the US in 2025, there were 2,000 venture funding events associated with agentic systems companies. So if you put agentic or agent into your company name, there was a literal gold rush of VCs pumping money into people that were focused on that particular area. We were focused on that area and we were quite early into it. But what we found over the course of 2025 is there were so many companies entering the space that it was getting confusing and it was getting very difficult to get any kind of market traction. So in April last year, we decided that we would pivot away from a horizontal agentic systems framework and we would do something that was a lot more vertically specific. And there were a couple of people in the company that came from a VFX, visual effects, and art and video games design background. And we decided that we would pivot the company towards creating generative AI tools for artists and VFX professionals. And we've been doing that since April last year with a new product called GripTape Nodes, which is actually built on the stuff that came before. But what GripTape Nodes is a visual node-based workflow editor for artists, video games designers, VFX professionals. It allows them to integrate large language models and agents together with state-of-the-art diffusion models. And if you're not familiar with diffusion models, I imagine a lot of people in this room are, diffusion models are typically used for media generation. So we're talking about things like Stable Diffusion, which was the first high-quality image generation model, and that's been followed by tons of sophisticated commercial and open source image gen models, things like Black Forest Labs, Qwen Image, and things that are in OpenAI and Google Vertex. You might have heard of Nano Banana, for example, which is another very much state-of-the-art image generation model. After that, video models came through, and there's a ton of video models now, Kling, Google VO, and others. We support all these. There were also open source video models like WAN, if you're familiar with WAN Animate. And then you've got audio. You've got from the open source audio models all the way through to things like 11 Labs, which is a very realistic speech and audio generation model. So with our product GripTape Nodes, we make it possible for developers to build workflows using all of these components, but more importantly, we make it simple for artists to directly access the latest state-of-the-art generative technology to create assets for advertising, design, movies, video games, TV, print media, all kinds of situations where you might want to generate high-quality visual or audio assets. We make it possible to do that with a GUI, with a drag and drop interface. So artists do not need to understand how to use WAN. They do not need to understand how to use Qwen Edit. We make it really simple to do that with this node-based UI that we provide. It's called GripTape Nodes. So obviously I'm not selling that to you guys. You're not visual effects professionals, so you're not the target market. Just trying to give some context of where we've been with the company. So this is what you get as an artist. You'll get something that looks like this. This is a compositing workflow. We've got a couple of static images, could have been drawn by hand, could have been generated by another generative model. We've got some 3D assets, could have been purchased from an asset library, could have been created using something like Hyper 3D, image to mesh, where you can take a flat image of an artifact and convert it into a 3D mesh that exists in 3D space. The artist then loosely, roughly composites those things together, and then we use a generative model to relight the scene, which meshes or merges the 3D assets into the scene, corrects lighting and shadows, and gives you a very cohesive visual output from these different component inputs. And that's how an artist would use GripTape Nodes in their workflow. We create the workflow, and then we bring in these state-of-the-art image manipulation, image to mesh type models, and the artists can use them without needing any technical skills to do so. That's basically the product. Last week, we were acquired by a company called Foundry. So Foundry is a leader in the 3D compositing space. If you're familiar with something called Nuke, well, let's take it back. If you've watched Game of Thrones and you've seen two people standing in front of a castle or a dragon, you know the castle or the dragon isn't actually there, right? They put it in afterwards. And Nuke is the technology that is the de facto standard inside studios to do that 3D compositing. So to relight and to make those 3D generated assets look like they're part of the scene. There's a lot of mathematics behind that work, and Foundry are the people that create the de facto tool for that particular part of the production process. And their intent is that GripTape Nodes will become part of their product portfolio and also will power future AI-powered features in the compositing and VFX space. So we got a win in the sense that we sold the company, we got our exit, and I think we're going to go on to do some great things now that we're part of a much bigger entity. But I'm not here to talk about that. I'm here to talk about something that's more from first principles, which is large language model applications. So what's so hard about building LLM-powered apps? And here's a question for you. What does the large language model actually do? So what do you put into a large language model, and what do you get out of a large language model?
Text or voice.
Yep. So you put in tokenized text or tokenized audio. There's a tokenizer, right, that sits in front of the model that converts whatever you put into it into a mathematical representation of the text or audio, right? And normally with audio, it's actually transcribed first, except in some special use cases like voice-to-voice translation, but usually it's transcribed with another model, and then it's tokenized, and then it's fed in. And what do you get out? More text, exactly right. So only thing that an LLM can do is take in a sequence of tokens and generate a corresponding sequence of tokens as a result, right? And where does the information come from that they use as the basis for token generation? Yes, and training data has a point in time at which it's final, right? So a large language model cannot tell you what the date is. It cannot reliably add numbers together. It cannot do anything which isn't in its training data. It can't reliably add numbers together, I assure you, all right? But when you use ChatGPT, the app, the chat app, it can do these things, right? It can tell you what the date is. It can tell you what the time is. It can reliably do pretty complex math. It can even find up to the minute information like who won the Super Bowl, right? So if an LLM can only receive tokens and generate tokens, when you interact with something like ChatGPT or Claude, are you interacting with an LLM? No, not directly. You're interacting with an application, right? An LLM-powered app. And that's really the crux. If you're building something that relies upon a large language model as a component of the overall system, you need to do the things that something like ChatGPT or Claude does, because when you interact with the APIs, with the application programming interfaces that are provided by OpenAI or Anthropic, you're not interacting with all of the sophistication that exists within a web app, like the web app that OpenAI or Anthropic provide. You're interacting with something which is much more bare bones in the functionality that it provides. So you need to consider a lot of other things if you want to get the complete feature set that exists inside the wrappers around these LLMs. And that's kind of the crux of this talk. Okay, the question is, how do you do that stuff, all right? And then the second thing is, this may be a controversial statement now, but most applications will not be chat. Okay, so most of the things that interact with language models will not be about people typing or, vocalizing their needs to a language model. Language models are going to get used inside lots of different processors, lots of different, in our case, creative processors. And in pretty much none of those cases does somebody type in and say, hey, I want to see a picture of A. They have their prompt for their image generation. Other things might happen to that prompt. It could be parameterized. It could even be system generated from another app upstream. So at no point does somebody type into a box to a language model what they want. They're interacting with these language models via the APIs. So what API do you want to build against? We would say, be cautious. There's a lot of leapfrogging going on. There's a lot of cost optimization opportunities available if you think about using open source models for some or all of your workload. Do you really need state-of-the-art Anthropic Opus 4.6 or GPT 5.2 with their high token costs in order to do simple things? In many, many cases you don't. And if you use them at scale, you'll find that you have very high bills for things that could reasonably be serviced by much lower cost or open source models. So blending different models together means that writing against the APIs provided by these model providers will kind of end up cul-de-sacking you into a land of very high costs in a lot of cases. So just think about that. We would say use a framework. It doesn't have to be our framework. We kind of don't really focus on positioning our framework anymore, but having a framework like ours, LangChain, AWS's Strands, Agent SDK, Google have got one, Microsoft have got one. Having one of these frameworks as a mechanism for abstracting the models is a very sensible thing to do in terms of the longevity of the systems that you're going to build. So use a framework. Maths, super interesting area. We used to laugh at ChatGPT and Claude before they actually integrated maths tools into their own UIs. You used to be able to ask them dumb questions like, what is, this one is 10,224 times 4,563 divided by 3.4, and I tested it with a few different models, and none of them could get the answer right, because they are sequence prediction machines at their most fundamental level. So they're kind of, guessing, but predicting that next most likely token and getting things wrong. And Anthropic actually did some really interesting research where they put their language models into a test harness that would allow them to sort of observe the thought pathways that existed inside the model as the model came to conclusions or went through its prediction process. How did they actually think about mathematics? And you can find this paper, this was in MIT Technology Review, the bizarre inner workings of the large language model, how they instrumented the models and started to inspect what was happening inside them. And when they looked at maths, they got some bizarre results. Like you ask them to do a large calculation of the type that I just showed, there's sort of two thought pathways that get lit up within the model. One which is devoted to calculating in broad terms what the answer roughly is, and then one that is devoted to precisely calculating what the last digit of the answer is. And then at the end of the process, those two things are kind of meshed together and it spits out something that it thinks is right. But of course, in a lot of cases, it isn't. So you can't use sequence prediction to do maths. The other characteristic here is the models can be non-deterministic, or you can sort of lock them into a more deterministic pattern using something in the API called temperature, which is a sort of randomness factor that is applied when models do inference. But in most cases, you'll find that asking the same question, 2, 3, 4 times will yield you 2, 3, or 4 different answers. So not great for systems where you want to have a degree of reliability. The other issue that you've got is knowledge, up-to-date knowledge of the world beyond the model. So they don't have current knowledge. Okay, so you ask something like GPT 4.0, what is today's date? If you ask that of the API, so not the chat GPT wrapper that you would interact with through your browser, but you ask it directly of the API, you'll get an unhelpful response like this. I am unable to provide real-time information, including today's date. Okay. But then if you interact with those GUIs, those web wrappers that you use as a user, of course you'll get that information. I'll explain how in a second. And then you can, do the Super Bowl test. Who won the most recent Super Bowl? The most recent Super Bowl, it starts well, but actually it's looking back sort of 2 years ago now, because the training cutoff was June 2024 for this particular model. So you're getting out of date information. So how do you solve things like that? And to solve this Super Bowl problem, actually two things you need to do. You need to understand the meaning of the most recent. So to do that, you need to know what today's date is, right? And then the second thing you need to do is to be able to fetch information to update the knowledge within the model. These are solved problems now, but they weren't at the time these models first emerged, and they're still not if you use the APIs associated with these models. So you need to sort of figure out how you're going to get around this. And the answer to that is pretty simple. So you're giving tools to large language models, but the large language model, as we've already established, can only take in a sequence and give out a sequence. So the tools don't run in the models, right? The tools run in some sort of computing or application environment that is interacting with the model. And the way you would set these up is you would say, make a request, this is my prompt, and these are the tools and capabilities that are available to you, model. I want you to generate a response to the prompt. When it figures out that it needs to use a tool in order to generate that response to that prompt, it would actually fire that back to the client, to the application, and say, I want to invoke the tool that you told me was available to me. And these are the parameters of invocation that I want to use. Now, something like today's date is super simple, right? You have a tool there, which is get current date and time. And then you return back to the language model, the response to that tool, which is the current date and time. There's not really any computation there. It's a system call on a computer. You're looking at the clock, right? But another parallel tool might be like a date time delta. I want to know what the date is going to be in 75 days. For that, you would need a tool which is a little bit more complex. That would be an add time to date tool. You would give it a time stamp and a date, the number of days, minutes, hours that you want to add to it, and then the tool would generate a time indication at some point in the future and provide that back to the model. And you can see this can enable things like reminder setting apps, all kinds of applications where you need deltas, that kind of tool could be used to solve that. And the same thing would happen. The specification of the tool would be provided to the model. You would make the request, tell me what the date will be in a week's time. That would fire back, invoke the tool on the local system. The tool on the local system would calculate what the date would be in a week's time, give it back to the model, and then you get a generated response back. So you get this quite complicated back and forth, even with simple tool calling. Okay? Now the downside with these tools is every tool has to be individually described to the model and made available to it. And there's no tool discovery beyond simply specifying what tools are available in each call that you make. So you're doing anything complex, you can have, 5, 10, 50, 100 tools. And when you've got 50 tools plus, you get something called tool resolution issues, which is it gets harder and harder for the LLM to work out which tool it's supposed to use to solve for a particular problem. And then the wheels can come off and things can get very kind of unpredictable and weird. So we needed a solution for that. About a year ago, Anthropic came out with something called MCP. A lot of you might have heard this acronym, Model Context Protocol. What we're actually doing here is providing a tool discovery capability. So a third-party publisher can make a group of tools available to access a service or access a set of functionality. And a large language model can discover those automatically by communicating with the MCP server, essentially sending a request over saying, list your tools, get a list of tool names and capabilities back. But MCPs can also wrap up other things. They can wrap up resources, which is another class of entity inside the MCP server. A good example of this would be something like file system access. So if you want your LLM-powered application to access the file system on a computer, the MCP file system access capability could provide a list of files in a directory or a list of directories that are available. Those become available to your app, they become available to your model to work with, so you can read a file and select a file from a list of different resources that are available. And then the last thing that you can wrap in an MCP server is pre-canned prompts. So I want to do something, what's the best way to get the large language model to use the capabilities inside the MCP server? We can actually package up a prompt and store that in the MCP server, and then our application code can access that prompt. It's got a template prompt that it can use that we've presumably tested and evaluated, and we're reasonably confident is going to give the results that the application wants when it's used with the large language model in conjunction with the tools. You can get quite complex systems here. GitHub, they've got 43 different tools in their MCP server. So you can get quite a large discovery space for different capabilities. And you will also find that more recent models have got more core training data inside their training set that teaches them how to interact with model context protocol servers effectively. So you go back to GPT 4.0, you would find patchy performance with MCP servers. You jump on to 5.2 or Opus 4.6, which I would consider state of the art right now. And all of a sudden MCP servers work like magic. You can do very complicated things with them. You can, write prompts like, find me all the issues on this GitHub repo where I am mentioned and prioritize them and tell me which ones I need to review most as a top priority, and it will do that work. It will go out, find you as an identity, find all those issues, bring them all back into context, evaluate them all, figure out which ones you need to interact with, and then feed that information back to you, and it'll do all that in one shot very effectively. So you've seen this real rapid ramp up in performance as far as MCP-based access to resources and APIs is concerned. But again, the same issue persists. You load 20 MCP servers into your agent, and things will start to get unpredictable. So it's about having the right MCP servers available for whatever task you want to operate upon. Make sense? So here's an example, one that I experimented with. The other thing to mention about MCP servers is they can be network-based resources. So for testing, you're probably running them on the same machine where your LLM-powered application is running. But if you're using something like the GitHub MCP, it's an endpoint on the network that you interact with, much like a web service. Well, it is a web service in transport terms, a slightly different protocol that's running across that connection. This one is an agent with 3 different things. So we've got something called Graffiti MCP. This is for graph memory. So it builds like a knowledge graph inside a graph database with entities, relationships, and you can use that in a general purpose way to provide searchable memory for your agent. Very, very good for software development tasks, but I'll show you a different use case here in a second. the file system MCP that I talked about, and then an MCP server for converting PDF format files to Markdown. It's very effective for large language models to work with Markdown. They've been trained on gigabytes and terabytes and petabytes of Markdown documents, so they're very familiar with how they're structured and how to extract information from them. So in this particular example, I took a couple of large legal documents. This is employment law documents, a judgment of about 100 pages and a remedy judgment of about 50 pages. So there's about 150 pages of legal text there. I gave a very simple prompt: read the files, load all the identified facts in those files into graffiti memory. Okay, so I sort of crawl through the PDFs, except the agent uses an MCP to convert those PDFs into Markdown. It crawls through the PDFs and it extracts key facts and relationships and then loads them into the graph memory using the other MCP that I have. And I end up with a graph that looks like that. That's all the entities and facts inside those documents loaded into Neo4j and visualized. It's a moderately complex graph, right? And then I can ask questions. So separate session. So there's no memory here of what's gone through the agent in terms of the prior context. So I go to the agent fresh and say, what was the ruling on the preparation time order? What factors were considered material in the ruling? What was the value of the preparation time award? And the agent extracts those facts from that graph memory and then does something similar to retrieval augmented generation to generate a text response, which accurately answers the 3 questions that I have. Yes?
What degree of confidence you have it was that accurate, and what kind of testing could you do?
So you could do evals. So, the way that you normally evaluate performance of large language models is systems-based testing. So we would generate questions, probably using a different language model. And then we'd have a sample set where we basically ask questions of the data set and validate them. But in this case, I actually read the judgments independently and validated the results that I was getting. Yeah. So another case where I use this so extensively is within the assisted coding context. So if you consider something like, I might have see if I've got another graph here. I think I might. Yeah, so this one, if I can get this onto the screen, is that going to appear? Maybe not. Yeah, I'm not sure I can get that on there. I've got another use case in front of me here, which is assistive coding. So what I do in my day job, a lot of my day job, is creating plugins and focusing on developer experience for the artist product that I was talking about, right? So those nodes on the graph, you can write code to create those nodes. So last week I did one which was like color transfer. It uses published research, color transfer algorithms, allows you to take an image and then transfer the palette from that image onto another image or onto a video. So to create that, I basically did quite a few coding sessions historically using a tool like Cursor or Claude Code. I use Cursor, but could use Claude Code. Every time I finish up a session of manual development on one of these nodes, as we call them, I would instruct my agent to load the lessons learned from this session into my graph memory. And over time, my graph memory ends up with, hundreds of facts, hundreds of practices, hundreds of entities within it. And then when I want to develop something new, I can provide a brief specification for what it is I'm trying to create. So I want to create a color transfer node. And actually with Cursor, you can do things like sketch out the UI that you want with pen and paper, take a photo of it and give the UI to Cursor and say, I want something where the UI looks like this. It takes an image and outputs an image or a video. And it uses these 3 color transfer algorithms that are available in publicly available research. I give Cursor the graph-based memory, and I give Cursor usually links or a web search so it can go out and find the algorithms that are required to implement the color transfer part of the code, which is the hard part, right? And using that approach with this graph-based memory, which I've built up over multiple sessions of writing these nodes by hand, I'm able to basically one-shot or two-shot most development tasks in our product, just by using practices that I've aggregated inside one of these graph-based memory stores, a couple of MCPs and a coding agent. When people talk about software development transformation with AI, that's where the sort of rubber really hits the road. Is like experienced engineers that have got detailed knowledge of particular code bases or particular systems, they can transfer that to an agent through the use of one of these memory stores. And then that can automate 95% of their work. 95% of my work that I would have done historically writing code is now carried by a coding agent. And that's literally how it works. So I can be like up to 20 times more productive by using this kind of technique. This is a legal case because I generally give this talk to business professionals and they kind of glaze over when I start talking about software development. Some of them do. But everybody knows that legal documents are a pain. You've got like loads of paralegals working in law firms doing case research and picking facts out of cases, looking for precedents. All of that can be automated if you load data from judgments and case law into a system like this. I think it's pretty interesting. Okay. So that's all about relatively simple agents, right? The other thing that you hear quite a lot about is agentic systems. We were talking about agent-to-agent systems, right? And the mental model that you should really use here is like, well, why would you have an agentic system rather than just one agent? Maybe that's a good question to pose to you. Why would you have an agentic system rather than just one very powerful agent? Context, you got it, yeah. So you overload your context window. Context windows are very long with modern models. I mean, Gemini 3 came out and their big sort of USP was 1 million tokens in context. The thing they don't tell you, of course, or at least don't shout about quite so much, is you pay by the token. So the more you load in, the more it will cost you. And the more you load in, the more confused your model will be. It's a little bit like tool overload, where you have, too much context, too many different facts. The agents get confused about what it is they're supposed to be focused on. So the way you would typically handle that is sub-agents, different prompts per agent, which are much more focused, even different rule sets per agent, which is like the system prompt that guides the way in which the agents behave. You would try to constrain that as much as possible. And I had a demo app which was hotel management, and I have like different agents with different system prompts and different tools. So say you had like a maintenance system, a guest could chat to the managing agent, the sort of orchestrator. They could report a problem that required maintenance. The managing agent would figure out which sub-agent was supposed to handle it. It would pass the problem off to the sub-agent, and the sub-agent would be equipped with tools. In this case, it might like be an API that allows you to open faults with a third-party maintenance provider on some sort of external software system. But that would happen at the sub-agent level. So you've got pretty constrained context and pretty constrained goals for each one of the different agents that you're using. And this sort of approach works really well with just one caveat, which is, the clue is in the name, right? Agentic systems is agency. Agency means you're delegating decision-making and control to someone else, right? And when you delegate decision-making and control in agentic systems, it's a little chaotic, okay? And sometimes they can need to swing the bat several times to hit the ball, or like have 5 or 6 putts to get the ball in the golf hole. And that means cost, because every time you run one of these API calls, tokens cost dollars, large systems, lots of requests. If you've got any degree of churn, you need to be able, and by churn, I mean like repeated invocation of the same agents over and over again. You need to be able to observe that. So I would say the sort of first step in building any sort of moderately complex agentic system is observability. But thankfully, most of the observability vendors now provide very good wrappers that enable you to instrument calls to large language model API providers and calculate cost. So you can see like token counts going in and out. You can apportion token counts to particular agents. And that will allow you to track down where in your system your largest costs are and let you tackle those costs if they become a problem. And they can become a problem. So that's the kind of the one word of caution about large language models is the bigger the model, the more the token cost is, the more capability it has. But if you're using them particularly at scale, you can expect to see some quite large bills. And the same on the video side, like generating a 5-second video with VO3 is like $4. So you're generating a lot of 5-second videos, those $4 can add up very quickly. If you've got an agentic video generation system, well, I wouldn't do that. That could get fast, very costly, very, very fast if you do something like that. So that's pretty much all I have on slides. If anybody's got questions, I'm happy to try and tackle any questions that you've got. The framework that we created at the beginning of our journey is still available. It's open source, Apache 2.0. It's still maintained, but we're not trying to monetize the framework or the cloud service anymore. We're focused now solely on the VFX. side of stuff. So if anybody's got an interest in the framework, then pick it up and have a look at it. And it's comparable to something like LangChain, but we think cleaner and a little bit simpler and a little bit more well maintained. And I think that is it.
Yeah, many thanks, Ian.
Thank you.
I'm sure there are a lot of questions. I have one or two, but I won't ask them straight away.
Okay.
Throw it open to the audience. Who's got the first question?
Yeah.
Yeah, so the graph-based memory store that you've got kind of performing code tasks inside your own code base.
Yes.
That seems like a really innovative way of kind of getting that concept into the model that needs it.
Yeah.
Why aren't Claude Code or other kind of agentic coding systems?
It's a good question, isn't it? I'm not sure is the answer. Maybe it's because none of them own a graph database company, so they would have to have a third-party integration. And Claude Code does seem really heavy, doesn't it, on Claude.md files, and you've got those static text files. But the problem is, I know they have some sort of structural model where they can basically find headings within the Claude.md using Markdown and strip out the section below them. But the thing about the graph database is it's both vector and lexical search. So when you do a search, every one of the nodes in the graph that I showed you before has an embedding calculated for it. So it's not just find me all instances of the word, I don't know, stable diffusion. It will actually do a vector similarity search for stable diffusion, and it will find it on that basis and also do a lexical search, which is more of a traditional keyword search, and it will aggregate results and present those back through the MCP. So you get, in my opinion, much better results with graph-based memory than you do with more traditional lexical search across memory because of the embeddings that are used. You all know what embeddings are, right? Yeah. Yeah, it's Neo4j under the hood. So, yeah.
You mentioned MCP servers and the tools that, so GitHub you said has a range of tools. So do you see the possibility in the long term of almost an app store type model emerging for?
You pretty much got that already. I mean, you pretty much got that already inside Claude Code, Cursor. They've already got their MCP store or MCP library that you can look at. So you can discover them. And if you go on to Anthropic maintain a GitHub repo that's got thousands of them listed. I mean, this is the problem, is proliferation, right? They're actually very easy to write. Writing an MCP server, I mean, it was trivial before, but now, of course, you can just point a generative model at your API and say, create an MCP server for this API, and it will create you one in a matter of minutes, and it will do it very reliably because there's so much prior art out there. So the problem, you're right, is discovery. And I think the other thing is trust. So there's been a precedence in the generative world, and we've had an example very recently with this thing called OpenClaw, which at least I hope some of you have heard of, which is installing random agents developed by people on the internet and then giving them access to your bank account, your IRS files, your social security number, everything, and then woe is me, everything's gone to crap. Well, are you surprised that it has? So the other issue with MCP servers, which is related to trust, is they're obviously quite often in the middle of systems that require credentials. What do you think a Google Mail MCP can do? Read all of your mail, send mail, delete mail. So you need to be trusting the people that provide you with these software shims because they're going to be giving them creds. And you shouldn't be throwing your credentials around. You need to make sure that you've got appropriate trust boundaries and principle of least privileges in effect whenever you do anything with third-party APIs. And there's a tendency, I think, with AI for people to kind of get carried away and discard some of the important security lessons that we've learned over the last 20 years, and they absolutely shouldn't do that. I have a colleague that I used to work with, Julian Simon, who's now a venture partner in a European VC focusing on AI, and his article that he wrote when MCP first emerged was MCP forgetting 40 years of security best practice in an instant. Very provocative, but actually very true. So yeah, you got to make sure you trust what the code you're running. Do you want to be giving random repositories from? Because quite often you install them just by pointing your MCP client software at a GitHub repository. It just pulls down the MCP server and nobody even looks at what's in the code base. That's dangerous, right?
Any more? Excellent.
When I hear about writing code with AI, the first thing that worries me is testing.
Yep.
Because usually people that use this tool to code, they don't even know that testing is needed.
That's right.
what is your opinion about
Write the test first, get the agent to write the test, and then get the agent to write the code and test itself, which would be best practice. But my real opinion is, people say like vibe coding, death of the software developer, no more software development courses. I think what will happen is software development teaching will go towards foundations, like foundation level skills. Like, I don't know how old are the people in this room. I'm 52. I was at Leeds doing computer science in the early 90s. The things that I learned about, it was C then, and then Java. So we learned C and then learned Java. The things that I learned then, as applicable now with JavaScript and Python and Go and these other, in quotes, modern languages, as they were back then. And if anything, those foundational skills become more valuable as the actual value and time taken to write code diminishes. The importance of things like you've just stated, that testing is critical, that becomes more important, right? Not less important. So I think that the nature of the computer science and software engineering curriculums will change a bit. But we still need professionals to guide these agents. Having people that don't have foundational skills guiding them, much like my comments about security, is actually dangerous to do. You know, you're going to have very, very irresponsible systems, very few controls, very poor testing, and there's going to be all sorts of unintended consequences if that's the sort of practices that people choose to adopt with this new technology that makes them 20 times more productive. You can do 20 times the damage in the same amount of time. Might be a good way to think about it. And I'm a strong advocate for AI tools. I use them every single day. I would not write code now without an AI assistant. I just think it's a very unproductive and inefficient way to do it. But you've still got to have the knowledge to use them in a safe and responsible way.
The companies are rehiring software developers. They've reached some sort of limit on the scale of projects they can work on. Is that a temporary blip, or?
I think that if you've got a very large system, a very large legacy system with poor decomposition of functions, you're probably going to hit that. So it doesn't sort of take away from the modernization imperative that exists within software, right? We've got systems lying around from the 80s and 90s that were, by modern standards, poorly designed, with poor demarcation between different services or different components. So maybe getting over that modernization hump will then make it possible to use these assistive tools. Or you've broken your monolith up into segments and it's more easy to understand. You've kind of got onto the service-orientated architecture bus, albeit maybe 15 years too late, but you've got onto it. And then once you've got an architecture like that, the different services become addressable by agents. I think that's more likely.
You mentioned going basic. So these systems will be complex. So what can you do at runtime debugging? Let's say something goes wrong.
So debugging is
to know exactly where it is.
Yeah, debugging is an interesting one. We talked about observability, right? So you need modern observability practices in systems that are being developed now. And the way that they typically work is by being injected into the runtime environment where your code is running and instrumenting different functions, different API calls. Will get automated instrumentation wrapped around them. And that will enable you to see how the system is behaving in terms of cost, performance, and reliability. But maybe the most important thing that I didn't really talk about in this session is the non-deterministic nature of the generative process. And to solve that, there's something called evals, or evaluations, which is the most common way that generative systems are tested before being put into production. And if you want to learn more about evals, one of the best resources I've found, there's actually a course on Anthropic's website. So Anthropic provides some free learning resources. They've got one called something like Developing with the Anthropic API. And inside that, there's a beginner's introduction to evaluations and how you would use them. And it's basically prompt response scoring. So you define criteria that you would consider to make the responses that you're getting back good responses. Yeah. And then you evaluate those responses using either programmatic approaches where it's possible. So if you said, for example, this particular prompt is supposed to return a data structure in this format or JSON or something else which can be validated programmatically, you can do programmatic evals to validate that what you're getting back from your prompts actually matches the format or characteristics that you want. And then for things that are a little bit more, subjective, using another model to evaluate the response from a model is a very common approach. But you would do this at like a scale of 100 or 1,000 iterations before you put a system into production. So you do like 1,000 tests and then if those tests pass on your subjective assessment, then you would consider that that particular prompt is good to go into production and you would do so. And then over time, you can adjust the prompt and further optimize it. And if your evals track upwards, you would consider that improvement of the prompt. But that's typically how you work with non-deterministic systems.
So thinking into the future, what do you think will come after agentic and MCP?
And that's a very difficult question. I think that, you know, as an AI advocate, this might be a weird thing to say, but I think now is the time to take a step back and focus a little bit more on safety and responsible practices in generative AI. I feel like there are, you know, a large cohort of people that are hyping this technology, okay, and are being far too permissive, far too aggressive in what they let it address. And despite working in the space, I still think probably the thing that needs to happen next is a bit of a retrenchment back into safety and responsible usage. And that might be a sort of counter answer to what you were expecting, but that is what I think should happen next.
Then like safety, responsibility and observability, what other pillars should we be putting into place to ensure that you're...
Well, I think cost, you know, like the cost management component of it is really important. Particularly if you're doing, like I said several times in the talk, doing things at scale is obviously, you can have very large cost implications from doing that. Yeah, I think that would be probably the four. Like knowing what your system is doing, knowing how much your system costs, making sure that you've got strong guardrails in place. Yeah, those would be the three maybe. Yeah.
I'm going to be that guy and ask the AI problem question. Do you think there is one? Because at the moment, all the model providers are losing money.
An investment bubble.
Just in general, like...
Yeah, I mean, what always happens with, you know, technology changes, people massively overestimate the short-term impact and massively underestimate the long-term impact. And I don't think this is going to be any different to any other big transition that we've seen. You know, you had the same with cloud, like in the 2015 to 2017 era. People were like employing these cloud-first policies and were jumping really hard on it. But of course, what happened, and they thought they were going to get competitive advantage by doing that, but of course everyone else was doing it, so there wasn't really any, it was a keep-up game rather than a get in front game, right? And I think to some extent the same sort of pattern's going to play out here. I do worry about the degree of investment, of course, and I worry about the climate impact. I mean, I'm a skier. When I was a child, I could ski in 100 resorts in France. Now I can ski in 20. So, you know, is it worth ruining the planet for super intelligence? No, we need to do it in a safe and responsible way, right?
Do you think we'll see a bit of a price crash or a price increase for these frontier models? Because
It's too hard to, I think it's too hard to call. I don't know. I mean, you've got training cost, haven't you? And then you've got inference cost. And those two things are somewhat separate. I do question as well, like, how far do you need to push it on model capability? We're almost getting to the point where they can't do everything, but they can almost do everything, you know?
Yeah, so it's kind of a related question actually. So you've built and gone through funding rounds, built the company, seen even the big players, the frontier models, get things like distillation tax.
Yep.
Big threat to the level of investment in it.
Yes.
Is there anything you have either done or learned?
What have I learned? I mean, I've learned from a sort of company building perspective, I've learned that everybody wants to go horizontal and capture like big market share with generally applicable solutions. But actually for a company at our stage, which was seed before we were acquired and actually raise an A round, that was not viable for us to do. We needed to be like way more focused on a particular vertical. So if you're in the company building game, if that's your idea, unless you've got like a really A-tier VC backing and you can raise huge amounts of money to build out product and GTM concurrently, then I would say that a focused effort is the way to go. Like, what is the small slice of the market that you're actually going to address first? So it's a prioritization game, really, I would say. And we've certainly had success when we've focused solely on VFX. We were doing something. There's one other competitor that you might know about called Comfy UI. And we address some very real issues that Comfy UI has with their license and with their product. We saw them very early. And we thought we're not going to end up in that same track that they've ended up in, where they've got GPL3, which makes it difficult for anybody to build a derivative product on top of their product. And they've also got this dependency isolation issue where if you have like extensions A, B, and C, C breaks A. Very simple. You know, you install more extensions and eventually you'll hit a dependency conflict and things will break. So we started from the beginning thinking that we're going to avoid those two things. And that's, I think, one of the things that's made us an attractive acquisition target. Yes.
General question. What are malign actors doing in this space?
What are?
Malign actors doing in this area?
So they're using large language models for nefarious ends. So they're like using them for sophisticated scams. They're using to simulate humans, like robocalling. You know, you could equally well take a voice generation model like 11 Labs and use it to fake someone's family member by using voice cloning. So there's a lot of opportunity for people to make criminal activity more sophisticated than it might have been in the past. That's certainly an issue. And then you've got the sort of, you know, not so much malign, but ethical questions about training data. Like, what do you train on? Where do you get what you train on? Did you get it in an ethical way? So that's, say again? Of course, yeah. Like industrial, this is the distillation thing that came out this week with some frontier models being sort of sucked dry by Chinese model providers that were basically training their own models using outputs from state-of-the-art US models. It's like industrial espionage via API, basically. Yeah, so all that as well.
Do you think these AI systems, do you think they need to be conscious?
Can they be conscious is maybe the question that you should be asking. I mean, when you interact with something, again, we'll go back to that picture at the beginning, the chat box, right? They talk about guardrails, so you can't do dangerous things, overtly dangerous things with AI models anymore, but remember that all the model can do is take in a sequence and put out a sequence of tokens. So most of the guardrails are actually external to the models. They're part of the broader system that exists inside an OpenAI or an Anthropic or somebody else. If you take an open source model, you'll find they have very few guardrails and will do pretty much whatever you ask. So, and this is one of the problems. Years ago, I was working on facial recognition at Amazon on something called Amazon Recognition, which was their facial recognition product. I got interviewed by the BBC and they were like, is it ethical? And I mean, it's a subject that should be close to your heart because you'll know about the racial discrimination in facial recognition models, right? And how they've been proven in the US to have racial bias. So you should know about it. It's something that's a very big topic. And unfortunately, the answer that I had to give to the journalist was, doesn't really matter. You can't uninvent it. It's public research. If Amazon don't do it, someone else will do it because you're literally taking a research paper and implementing it. And you can measure similarity between two faces. It's just a fact. You can do it with maths. You can't sort of take that back in, right? So the way that this needs to be controlled is through regulation. Governments need to regulate. Governments need to mandate safeguards. Governments need to mandate a proxy for consciousness that will make the models behave in a responsible manner because the models themselves don't inherently have that in them. They're just like trained on all available public data. So if there's bad behavior in all available public data, models will behave badly. You know, so you've got to have guardrails external to the model that make the system behave in a humane and responsible way. Make sense?
Just going back to the start of the presentation, and you talked about grip tape and the work that you've done there.
Yep.
What's the underlying technology that you're using in the graphics video space?
So,
Certainly not LLMs, it's another.
no, it's diffusion models. So, and diffusion models, and largely we use something called Hugging Face diffusers, which is an open source diffusion model library from Hugging Face, the AI research company. And basically what you do is you get an open weight model and you get an open source tokenizer. You put your image or video generation prompt through the tokenizer, it generates tokens, you put them into the model runs on some computing hardware, and then you get a video or image back or audio back from it. So that's the sort of most basic way to do it with open source models. You need a powerful, and I mean a powerful GPU, and you need a crap ton of memory for the big state-of-the-art models. Some of the models are like 350 gigs, so you would need 4 NVIDIA RTX 6000s at $10,000 a shot to run inference in a 350 gig model. So you need like heavyweight computing hardware. And the large LLMs, the frontier LLMs, are quite similar in size. They're like hundreds of billions of parameters, and they're sitting in 128, 150, 180 gigabytes of memory. That's why when people say open source models, typically what they're running is quantized models, which don't have the same kind of floating point precision in the weights inside the model, and therefore don't have the same kind of fidelity in generation, but will fit in like a 32 gig NVIDIA 5090 graphics card, which is what I have on my workstation at home. So you could sort of scale them down. They lose a lot of the definition and nuance in the way in which they generate. So that's on the diffusion side. And then we run, all of our code is written in Python. Diffusers is a Python library. So for the open source models inside the nodes that exist on our node graph that I showed you at the top of the session, I'll just go back there to illustrate it. Might even have an open source one on it, I'm not sure. So I think this is Flux. So this is an open source model. Behind that is a Python class. So that particular component, UI, is a Python class which defines, it's a Python class with a constructor which defines the UI, and then a method on the Python class called process. And inside the process method is buried the diffusers call. So when the node gets executed within the graph, the method called process on that node will get run, the diffusers call will get invoked, and a generative process will take place on the GPU hardware wherever the engine for this system is running. So that's the sort of open source way of doing it. If it's a commercially available model like Stable Diffusion API or Black Forest Labs API running Flux, then that process method has an async request to that API in it. We send the prompt off to the third party, the image comes back and we render it into the node. And the third party has the RTX 6000s or A2000s or whatever in their, not render farm, but inference farm. Yeah.
So do the diffusion models have the same non-deterministic?
Diffusion models are the most non-intuitive, counterintuitive thing you've ever encountered in your life. Do you know how they work? I'll explain. This will made me, like, my mind just exploded when I first encountered them. Diffusion models, you start with the picture. When you're training them, you start with the image that you want. So I've got a yacht, a picture of a yacht, right? And I'm going to run weight randomization and training to convert that picture of the yacht that I've got in my image into white noise, into random noise in the image. Okay, so my training data is like in reverse. I train by converting concepts and images and image characteristics into garbage. And then when I want to put the model into production, I flip it upside down. I start off with some garbage and put in the same tokens, and magically a picture of a yacht comes out.
It's the same picture that you put in?
No, it's not the same picture that you put in, but it's a yacht. It has the characteristics, the same attributes, the same concepts will be present in the image. But it's the most, I mean, I cannot imagine something less intuitive than that process. It's like training by destruction, and then you flip that around and, like, you imagine blowing up a building and it automatically reconstructs itself back into a tower block after you've detonated it. That's basically what happens in a diffusion model.
I think this follows on. There's been an issue with incorporating text within generated images. Is that something that will always exist? Or is that
It barely exists anymore. It barely exists anymore, that issue. You go to Nano Banana, QuenEdit, Flux 2, the big, large parameter Flux 2 models, it works absolutely fine. Yeah, so it was an issue, but
With that, the more text that you do have within an image, it will still...
it gets harder the more text that you have, but they're many orders of magnitude better than they were even 6 months ago now. You can, like, literally give a wall of text to Nano Banana and say, create me a graphic, an infographic, which, you know, summarizes these corporate results, and it will draw you graphs, it will write perfect text, it will annotate axes, it will do everything. The level of acceleration in quality of image generation models. I've been in the space I started in April last year, not even a year working in this space, and I used to laugh at text generation. I've got loads of examples on my computer of crappy text generation. And over the year I've been testing, like I had a blog post I did a long time ago about Black Forest Labs, which is my favorite image generation model, the Flux series. They're photorealistic, they're sort of super They've just got a sort of ethereal quality about the way the images look. They look great. And I would start with this test, which was a snowboarder in a half pipe in the forest in front of a building which says Black Forest Labs with a neon sign. And it would be garbage when I started. Now it's absolutely perfect. The lettering is beautiful, the lighting is amazing, the forest looks fantastic. So, and that's less than a year after I started that test.
Is this an improvement of the models, or is this sort of like a plug-in?
No, it's an improvement of the models. It's an improvement of the models. But I wouldn't be surprised with something like VO3. Sorry, Nano Banana is very good at it. I wouldn't be surprised, because these are like black box systems, right? What would I do if I wanted to make a really effective text generation model? Well, there are really effective text extraction models, right? Where you can read text out of images using AI models. So wouldn't it make sense to evaluate the image that was generated to make sure whether the text was correct before you actually returned it to the user? And how do you know whether Google are doing that or not? You don't. So another type of optimization that can exist if you apply a bit of sort of systems thinking. The main thing about these API models is nobody knows what goes on behind the API endpoint. Yes, they're generating images, but what are they doing at the beginning with tokenization, prompt engineering, prompt enhancement, and what are they doing at the back end? And how do you know they're not generating 10 images and quality assessing all 10 of them and giving you the best? You've got no way of knowing that. You just don't know how these APIs are built, right? There's a lot of engineering that you could do to make them better if you were like in that game.
First, just a second, fusion models. First time that was explained to me, I found it happening that they work by magic.
Yeah.
You mentioned OpenClaw, and as you said, a number of things going around the internet recently, which basically boiled down to I uploaded all my personal information to the internet and it didn't end well.
Yes.
Who would have thought? But I think moving away from the technical side to more the market side, one of the reasons it has been successful in its small space is that it's abstracted away some of the difficulties and complexity.
Yep.
And unfortunately, therefore, some of the security concerns
yep.
you should have. Do you think this is the first of many tools which try to do that, to try and make that kind of agentic system?
Yeah, I think there's already lots of stuff out there. I think for some reason that just managed to catch a wave in a way that we've not seen before. But do you know Comet, Perplexity browser? I mean, that's another, I think probably even more amazing than OpenClaw. You can I use it for some gaming related stuff, but you can basically go onto a website, open a browser panel, which will open up next to the website and just type in book me a flight from Manchester to Turkey on the 15th of January 2027, I want to pay $37. And it will go away and it will do all of the work in the browser with agentic automation, and it will basically get that transaction and say, just click if you want me to book it. It's every bit as magical as something like OpenClaw. It just didn't quite catch the wave of awareness in the same way.
I think with OpenClaw, the thing which really caught people's imagination was that it just did stuff proactively.
Yes.
Blessing and a massive curse.
Yes, yeah. And the sort of long-running nature of it as well, the fact that it's got the scheduler tool built into it, so you could give it things like look at this every day, and it would return and look at things every day for you.
One of the things that it's also done is obviously shown that the business model of the big providers at the moment, when it comes to general public use, is obviously predicated on the fact that it will be essentially used as a chatbot with one person sat in front of it, and there's a limit to how many questions they can ask.
Yeah, that's correct.
Do you think this is going to shift that?
I just don't think chatbots are the main. I just don't think chatbots are the main game. I think chatbots are like Gmail, but API-based access is like SAP. Everything else that exists in the enterprise software world, there's so much custom software out there now that can have generative systems plugged into it in some way or at some point. I think that's the main game. I think the main game is how do you make businesses more efficient and government more efficient, faster, and ultimately lower cost by using this kind of technology in existing and new systems. I just think chatbots, I might say this, I think they're somewhat of a distraction, really.
Absolutely. I guess my query is more around, I agree with you. I think we're not in a position where it is useful on a mass market level. But if you look at it in terms of IT adoption in the past into organisations and businesses, it's obviously following a similar pattern, but seems to be super accelerated in terms of the take with AI. Do you think something similar might happen with it?
I was chatting with this gentleman over here. I don't think that the perceived acceleration is necessarily reality inside most large enterprises. I think and this has become, I've been a victim of this, and also, you know, to some extent in my job at Amazon caused it. I think there's a phrase, isn't there, the future is here now, it's just not equally distributed. I think that this is yet another case where that is true. There's some people are far ahead and they get a lot of attention. But you know, I think OpenClaw's got like had 100,000 downloads or something, right? There's 850,000 people working for Accenture worldwide. There's 1.3 million working for Amazon. Is 100,000 downloads actually significant in terms of overall global market ecosystem impact? No, it's not. It's like a tiny little segment of the potential addressable user base, right? So we can get overhyped on, wow, look how fast this is moving, but it's the people at the front edge that are moving increasingly fast. And the average guy in business is probably looking and thinking, oh crap, I need to catch up. How am I going to do that? And it's the how that's the hard part, right?
Question there? No?
I did have a question.
Yeah.
So I've talked to you about this before, but in terms of people being resilient to the change, especially people that have been doing their crap for 20 years, is it going to get to a point where they're just going to have to bite the bullet?
Bite the bullet?
Yeah.
I think like every big change drives a lot of skills reinvention, right? And there's always a question about like how will this affect the work that people do. We had it with cloud, right? Cloud computing. I started my career working in a data center, racking machines, plugging in network switches, installing operating systems from CD-ROMs. It was a long time ago. That type of work just doesn't exist anymore, right? It got disrupted by cloud computing. It got disrupted by automation in software deployment. It got disrupted by innovation in systems building. So we just don't have those roles anymore. You got like, I saw something about Amazon laying down $12 billion of investment to build data centers in Louisiana, and they're only going to have 450 people working there. I mean, that is nothing in terms of the amount of square footage footprint they're going to have. So you get these waves of change. And I've said, you know, before, the people that survive and thrive are the people that reinvent themselves. You kind of, if you're sitting there saying, I'm not going to change, I'm not going to change, I'm going to continue doing things the way I used to, you're going to have a bad time. Yeah. So, you know, you've got to sort of, like I said, my software development work, which is probably 40% of my role, it's completely transformed over the last year. I was a, you know, good systems architect and a poor developer. And now I can put those systems architecture skills to work and become an acceptable developer and produce production quality code for a meaningful product. I couldn't have done that a year ago. So it's changed the way I work, but it's also made me so much more productive. And I think that's the mindset that you've got to have. It's like, how can I be more effective in my role by using these tools, using this technology? Because you're going to have change. You can't, you know, it's a kind of a truism, isn't it? You can't resist gravity. You can't resist change. You just got to kind of be the person that moves with it, try and fall down that hill in a safe way.
You mentioned measuring cost tokens.
Yes.
How conscious the developers and also yourself as a leadership team managers are in that? Is a new way of measuring it.
You've got to be conscious of it, I think.
Are they?
Yeah.
Have they got their experience, or is that why people are?
I think that's one of the reasons that people are kind of a little standoffish. Yeah, particularly with, you know, the sort of creative media models that we work with, the per run costs are high. You don't have that with token costs. You have, like, you know, to run an agent is going to cost you 1/100 of a cent maybe each time you run a text-based agent. Each iteration of that agent might cost you 1/100 of a cent in tokens. It's when you have large token counts that are being put through the systems, or as I've said loads of times, you know, you've got high scale, you've got that agent firing every 30 milliseconds because your business is operating at scale, really high scale, then you're going to have high costs, and you've got to be cognizant of that. And I think it's, again, quite similar to cloud cost management. You know, you've got your instrumentation, your emitting metrics, you can track your usage over time, you're able to hone in on particular agents or particular functions that drive high token counts, and then hopefully you've got some systems architects that are commercially minded that can come along and do cost optimization on those. Maybe strip out things that don't actually require a model, use an open source model, but then you'll have compute costs, so it's kind of trading X for Y. But there are techniques that you can use to control things, but the main thing is visibility, right? You've got to have metrics, you've got to have instrumentation, so that you can track what your spend is and hone in on the areas of high spend. Without visibility, it's like literally driving a car with the windows covered over in paper, right?
Just on a more broad perspective, right? Do you think AI
Do I think it's creative? No, I don't think it's creative, but I think it can be used by creative people to create amazing things, but I don't think it's inherently creative in its own right. Because it's, you know, it's trained on existing art, right? It's like, not art in the sense of paintings, art in the sense of things that already exist, right? So, no, it's not really inherently creative, but a great artist can use it as a tool to create things that are incredible, you know, that are incredibly creative. And they can do that at a speed and across media types or output that is much greater than they might have been able to address if they weren't enhanced by those tools. Yeah.
What if it lands on its own? What if it lands on its
Well, current systems don't really do that, right? People talk about like model improvement, but they don't really, the models themselves are not inherently able to improve themselves. What they are able to do is create better software that might help them train more effectively, or might help them be better guarded or wrapped around by systems of the type that I've talked about that give them new features and capabilities. But in terms of the token generation, it's, you know, tokens in, tokens out, and what you get out is defined by what that model has seen during its training, pre-training and training phases. So they're not inherently creative, but they can be used by creative people. Yeah, I mean, it's a really big area of discussion, isn't it? You go to like video games forums, people are raging about assets in video games being created using generative technology. Hopefully some people play games like I do and know about this trend. But I'd be surprised if there's many studios that aren't using AI as part of their pipeline, their asset creation pipeline, or aren't using AI coding assistants to write things that are in video games. I wonder why it's so emotive in, you know, some people have a really negative emotional reaction to it. And I guess the answer to that is slop. You know, they've seen one instance too many of garbage, which has been created by somebody lazy using a generative model. But if you're not lazy, if you're genuinely creative, if you've generally got artistic flair, you can use these generative models to create things that it would be impossible or too costly to create without them. So you've got both sides of that coin, I think. Certainly, we've got two artists on our team, one animator and one person that comes from a CG background. And some of the things they create are mind-blowing. Like the animators got a photo of himself, and before the whole action figure trend, he actually animated himself as an action figure presenting at a whiteboard using a generative model to convert a load of frames from video stills into this animated style, so it looked like a plastic figure. It was really, really cool. And then the artist that we've got on our team, Maru, has actually won prizes at a couple of film festivals for generative AI, and it's like animation stories, really amazing stories that are about equality and social justice in Latin America, which would have been kind of impossible for him to make as an individual creator without these tools. But he's able to produce a 5, 7, 11-minute short movie in just a few weeks by using these tools as an individual artist without an animator, without a compositing team, without anything else, just his own creative vision and some tools that allow him to create things. So you can get a huge sort of force multiplicative effect if you have the tools. That's on the creative tooling side that we've built.
When I first heard you speak, which was a while ago, I have a feeling you were talking about frameworks, and it was before MCP.
Yeah, before it came out. Yeah.
And so it sort of illustrates and that wasn't that long ago.
It was a year ago, probably.
Right? Yeah, just over a year ago. So that rate of change.
I've seen some things change in my career, but I've never seen anything change this fast. We're getting new generative models on the image side coming out every week, and we've got artists saying we want, Quen Edit, 57 billion. We want it tomorrow. We came out yesterday. Yeah, but we want it tomorrow. And then a week later, Seedream have jumped ahead again with Seedream 5.0. So the rate of velocity on the research side of things is just, I've literally never seen anything like it.
Do you think that's going to continue?
For the foreseeable future on the media side of things, yes, because there's still a lot of room for growth on the media. Yeah, I think on the text models, the LLMs, I think we're getting close to what's needed, But I think on the media generation, then there's still a lot of road ahead. It's probably how I'd characterize it.
Excellent. Any more questions? Okay, yeah.
I keep reading white papers about the general productivity boost that employees are seeing when they're asked to use these AI
Yes.
tools. There's a big downward pressure from kind of the higher execs to say everyone must use these tools. I
Yes.
think Accenture is one of these that
Yeah.
measure employee performance via
Tool use.
tokens.
Yeah, yeah.
and how
Tool
many
use.
tools
Yeah.
they're gonna use. Like, but the actual productivity benefits that people are seeing are in like the low single-digit percentages in a lot of cases. So I wonder what you think is the big barrier to unlocking this 20x productivity.
Well, I think I was talking about software engineering, right, and at the senior end of the spectrum. So you kind of got to think about what is the skills and context that the individual brings to the tool, and that's going to have a big effect on the amount of leverage they get from it. That would be one thing I'd say. The other people are going to be on the bus. Some people are going to be getting on the bus. Some people are going to be sitting on the bus stop not caring about the bus. And so you'll get productivity gains that vary across those different personas depending on where people are. It's very much harder in regulated environments where you might have compliance concerns about data that you can send to these API endpoints. So there's a lot of factors that can influence it, but I think the sweet spot is in software engineering, lifecycle management, where you've already bitten the bullet and gone towards the service-oriented architecture. You've got smaller teams with higher ownership. You've got robust SLDC tools, test-driven development, CI/CD pipes. You can then start to integrate tools like Claude with those, and you can get some phenomenal results. But your mileage will vary based on a lot of other factors. Yeah.
Excellent.
I noticed you nodding vigorously when I was talking about larger org inertia, and you think that that's a factor? Yeah. When I was talking about how change varies in organizations of different sizes.
Yeah, I just think with some of the small teams I work with, we get that fast feedback.
Yes.
Especially the software engineers, so I can see massive accelerating speed.
Yeah, I agree with that.
Just to back on that, my proper job when I had one was in project and program management.
Yeah.
I think part of this, the efficiency improvements of BC, that's true with any technical tool like you put in place originally. It takes a long time
Yes.
for people to get comfortable with using it. You mentioned the different, where people might be on the bus, you forgot the group who are also just trying to slash the tyres. And the take-up will vary massively. It very much depends on the industry you're in.
Yeah.
I worked a lot with public sector.
Yeah.
With one organisation not too many years ago that I worked with, there were still some of their senior management team who weren't even comfortable with the fact that they had email on their mobile phones.
Yes.
In terms of picking up technical improvements,
It can take serious amount of time. Yes, I agree. Totally agree. Yeah.
Sorry, just a quick one. So based on security and our trust for the models, quick story. Just this morning, a friend that texted me that he's had about 10,000 mails sent overnight.
Yeah.
He's done a cron job. He didn't read through the code. He's done a test with the AI.
Yeah.
The AI written the test and wrote the code, and then he's passed it on and he's pushed to production. And this morning, he's got about 10,000 mails sent. He's put a limit on. We had a conversation about some weeks back. I told him you have to put a guardrail, like Claude AI. They have this slider. You just put a limit on how much you want to spend on tokens.
Yes, yes.
So he's put that on, and then he's put his emails at max 10,000 for I think a week or so.
Yeah.
So this morning he's woken up and then there are mails over the night, and his Anthropic, what do you call it, had got to the limit where he put it on. So what happened was he set the cron job up. He didn't read through the code.
Yep.
He looked through the test. But so for me, I started programming 2020. At the time, if you write in your test, you kind of have this vision of what you want to guide against, what you think you want to watch out for. But now, especially myself, I noticed it a lot. If I put on AI and then it runs through, I have to sleep in bed and then think about, I didn't try this, I didn't even look, and then I go back.
Yeah.
So we go to that level of trust where we kind of leave it off to the AI. It does it all, and then we start getting repercussion.
Yeah, so this is back to the question before about like cost limits, guardrails, cost analysis. I think that's all good practice. And I bet your friend is glad that they put that threshold in there and didn't blow through that spend level, right? So they did the right thing.
Like it's there.
They did the right thing, and I guess the other thing is like, you know, human in the loop, where you're going to have your AIs making decisions, but then some human person has to say, yes, I agree, yes, I agree, yes, I agree, yes, I agree. It's fine at small scale, right? But what if you had a legitimate need to send 10,000 emails, and then you'd have to have a person approving them all? So you need to find the right sort of balance of guardrails and control and what your actual business needs are. What is the use case that you're trying to serve? Because I think, you know, if Amazon put a person in the loop every time they sent out an AI generated email, they'd be bankrupt tomorrow. So you got to sort of think about what's your organizational scale, use case requirements, and then what's an appropriate set of safety controls for that. But it's a great anecdote, and I think illustrates a lot of the topics we've been talking about.
Sorry, just one more back of these. Given your technical background, particularly in cloud and network, do you think once we enter this universe of agentic AI, we're talking to each other, APIs and everything, do we have the correct and enough infrastructure to handle all this traffic?
Traffic, yes. Traffic, yes. Yeah, traffic, I think, yes. I think the challenge is on the compute infrastructure side of things. The amount of investment that's required in the networks, optical networks, is not significant in comparison to the amount of investment required for the compute farms. So it's that will sort of gate the amount of traffic that can be generated on the network, I think, anyway. Yeah.
Is that where quantum computing is solved?
Don't know about quantum for AI. It's not really like... It is, but it's a different kind of computing power, isn't it? The main thing that you're doing when you're doing any sort of inference is you're loading a large model, and a model is basically a way to flow tokens through multiple layers of transformation. So when you talk about the memory footprint of a model, I talk about a 32 gig model or a 150 gig model. There's so many tensors or interconnect points in the mesh that represents the deep learning model that the aggregate of all those different weights consumes that much memory. And then when you put your tokens in at one side of the model or the top of the model, depending on how you think about it, the tokens arrive, you know, in a large array at the top, and then they're operated on by the different layers within the model, the different parameters or tensors, and then out of the bottom of the model, after all of those calculations have been done, flows another set of tokens, which is the result. The reason that the computational requirements are so high is the models can be very wide. You know, you've got how many layers? Thousands of layers, but horizontally maybe millions of parameters. So doing all of those math operations to figure out how your tokens get transformed as they flow through the model is phenomenally computationally expensive. And the reason that GPUs lend themselves so well to this kind of use case is that you do the same thing when you're rendering a 3D scene. You're taking in data about the scene and spitting out pixels at the end, but you're doing the same sort of matrix maths operations on the scene rendering process. And that's why a GPU for graphics and a GPU for AI is the same thing. But it's the amount of memory to hold the tensors for the model and then doing all of the maths operations as you flow data through it. That's where the computation is. It's not really a quantum operation. It's a different kind of computing, as far as I understand it anyway.
Seeing all this, like, because every day you wake up on this, YouTube, there's always something that you don't know where to, like, even start sometimes. You probably maybe even working on something, and next thing you check Twitter, someone has built it. Right, or you probably just, but seeing all these like changes, right?
Yes.
Right. Do you think you know about AGI, right?
Yeah.
Do you think we need it? Do you think it's needed? Or
Do I think it's needed?
Because there are several tools these days.
Yeah, I don't think it matters if I think it's needed or not. I mean, I think that, you know. Yeah, it's back to what I said before, right? You can't undo research. You can't undo invention. When we're getting into these frontier areas, what we need is governments to be responsible and regulate this technology. That is one thing that I would say is above my pay grade.
I think we're sort of getting close to the end of time, so is there one last question for Ian before we conclude the proceedings? No? Okay.
Thanks for coming, everyone. I really appreciate it. Great questions, as usual.
Many, many thanks to the way you've handled the
no problem.
questions. That's absolutely superb. So join me in thanking Ian again.
Thank you, everyone.
Just sort of let everyone know, obviously we're running these, you know, as Christina said at the start, as a monthly event. So we're really trying to be the the regular monthly meetup for AI. I mean, there are lots of other AI meetings. I go to them as well, and some of the people in the room do as well. The next one will probably be in a month's time, but the details are just being finalised as we speak. So probably overnight tomorrow, Christina will send out an email with the details for the next event. So look forward to seeing you in a month's time, and months going into the future. So many thanks again for joining us again today. Thank you.